Okay, I've got some problems here for the test review. I would say if you can get through these problems, you'll have a pretty good understanding of the material that will be on test 1. So let's take a look. The first problem here, we're asked to subtract these two expressions. And you might remember, if we have a subtraction sign outside of parentheses, we need to treat that like a -1, and we're going to distribute or multiply throughout the parentheses. So if we do that, we'll end up with a minus 6x cubed. A negative and a negative is a positive 6x squared, and a minus 7. We'll bring down the terms from the first expression. Now we're ready to combine like terms. I can see we've got a 3x cubed here, and we've got another x cubed term here. 3x cubed minus 6x cubed would be a negative 3x cubed. What else? We've got an x squared term here and an x squared term over there. So that's negative 3x squared plus 6x. And negative 3 plus 6 is 3. Oops, yeah, a positive 3 x squared. I see an x term here, but I don't see any other regular x terms, so we'll just bring that down. And then finally, we've got our minus 7 here, just a number, and we've got another number over here, another minus 7, so negative 7 minus 7, oops, negative 7 minus 7 is negative 14. We've combined our like terms, so we've finished this problem. All right, let's take a look at problem number 2, asking us to find the product or multiply these two polynomials together. And you might remember that this is the handshake method. So we'll start with the first term. He's going to shake hands or multiply by the first term over here. 5 times 25 is 125. And y times y squared, remember we add the exponents, so that would be y to the third power, because 1 plus 2 is 3. Continuing on, 5y is going to go and multiply by 35. 5 times 35 is 175. And y times y, that's y1 times y1, 1 plus 1 is 2. Finally, the 5y will multiply by the 49. 5 times 49 is 245. And we still have our y there. Okay. Now we can go with the negative 7. The negative 7 is going to go and multiply by the 25. That's a negative 175. Y squared. Negative 7 times 35y negative 245 y, and negative 7 times 45, or sorry, times 49, is negative 343. Now it's kind of like the last problem. We're ready to just combine like terms. I don't see any other y cubed terms, so we'll just bring that down. We've got a y squared here and a y squared here. Well, 175 minus 175, those will just cancel out. I see a positive 245 here and a negative 245 here. Those will cancel out. So that just leaves us with this over here, this minus 343. And we've finished that problem. Number 3, we're asked to factor out the greatest common factor. So remember, on these problems, we first need to find the GCF for the numbers. And for the variables, it's easy. You just find which letters they all have in common, and you take the smallest exponent. So we'll do that now. I think, let's see if I can, yeah, I've got that in there already. I wrote down some factors for 112, 128, and 48, and they're listed here. For instance, ways we can make 128 would be 1 times 128, 2 times 64, 4 times 32, and 8 times 16. So I wrote those factors out for each of these, and we're looking for the greatest common factor, so the biggest number that goes into all three. And it looks like to me that that's going to be 16. Notice how 16 goes into all of them. So our GCF so far is 16. Now looking at our variables, all three have an x, and the smallest x is x squared. So we'll add that to our GCF. All three have y's, and the smallest y is y cubed. Alrighty. Once you have your GCF, we can factor it out. That's going to leave us with some stuff on the inside. And actually, let me move this out of the way. And we'll bring this up. Okay. Now remember, when you factor out the GCF, when you pull it to the outside, all you're really doing is dividing each term by the GCF. Okay. Well, looking at this, 112 divided by 16, that's 7. And remember, by the quotient rule, we subtract the exponents. So 5 minus 2 is 3, so we'll have an x cubed. And 9 minus 3 is 6. So we'll have a y6. Looking at the middle term, 128 divided by 16 is 8. So we'll have a minus 8. 2 minus 2, those are going to cancel. And 7 minus 3 is 4, so we will have y to the 4th. Finally, on to the last term, 48 divided by 16 is 3. 4 minus 2 is 2. And 3 minus 3, those cancel out. So our final answer there, with our GCF pulled out, is shown, and we're done with that problem. Number 4, we're asked to factor the polynomial. This is where we're going to need to know the AC method. And remember, this is A, and this is C. And we start the AC method by multiplying A times C, which would be 12 times 5, which is 60. And then we look for all the factors of 60. 1 times 60, 2 times 30, 3 and 20, 4 times 15, 5 times 12, and 6 times 10. I think that's it. But we're looking for a set of these numbers that also combine to make negative 32. So we need a set that also combines to make a negative 32. Well, 60 plus 1, that's 61. 6 plus 10 is 16. That doesn't look like it'll work. In fact, none of these look like they will work except for 30 and 2. But we need a negative 32, so the only way to make that is if they're both negatives there, which still works out. A negative 2 times a negative 30 is a positive 60, and negative 2 plus a negative 30 is negative 32. So those are our two choices there. Next, we'll rewrite our trinomial, but we've got to split the middle term up using the two numbers we found over here. So instead of writing minus 32n, we're going to write minus 2n minus 30n, and we are ready to go. Now it's a factor by grouping problem. So we can split it down the middle. And we're looking for a GCF for these two terms. Looks like 2 is the biggest number that goes into both of them. And they both also have an n. So we'll pull that out, meaning we're dividing each term, leaving us with 6n minus 2n divided by 2n is 1. So we'll have 6n minus 1 there. On the second group here, looks like they both have a 5, and remember, if your first term of a group is negative, you want to pull that negative sign out as well. So we'll pull out a negative 5. Leaving us with 30 divided by 5 is 6, and 5 divided by negative 5 is a negative 1. These two pieces match. That means we did everything correctly. And notice they both have the 6n minus 1 in common, so that is kind of like the GCF of those two terms. We'll pull that out, leaving us with the 2n and the minus 5. And that'll be our factored form for this problem. On to number 5. We have two problems here. We're asked to solve these equations. So these are algebraic equations, and we got to solve for the given variable. All right, on this problem, it doesn't look like there's much to do on this side at the moment, so we'll start over here. I see I can distribute this 3, so I'll go ahead and do that. 3a, and then 3 times 1 is 3. Still have our 17a and our 7, so we'll just bring everything down. Then we'll combine like terms. So we've got 3a plus 17a, that's 20a, and 3 plus 7 is 10. Bringing everything else down. Now we're at the point where we kind of want to get all of our variable terms on one side and all of our constants or regular numbers on the other side. So I'm going to move the 3a away from the left by subtracting it. And we got to do that on both sides. And if I'm moving the 3a over here, then I'm going to move this 10 to the left. So the 3a gets canceled over here because 3a minus 3a is 0. The 10 will get canceled over here, and we'll have a negative 18 equals 20 minus 3 is 17. And the final step to solve for a is dividing both sides by the number attached to a, and we will get, oops, a equals negative 18 over 17. Looking at this 5b problem, we've got some fractions involved, and anytime we have fractions like that, I like to find a least common multiple, or a number, maybe a least common denominator, a number that both of these can go into. And the LCM here looks to be 28. 28 goes into 28, and 4 goes into 28. So then what I'll do is I'll multiply everything in the problem by the least common multiple. And the reason we do that is because it makes it pretty easy to cancel some things out. 28 over 28, those cancel, leaving us with 3y. 28 times 8, I don't know, but we can use our calculator here. That's 224. 28 times 7 is 196. And here, the 28 divided by 4 is 7, and 7 times 7 is 49 with the y. So now we've got a problem that looks a little easier to solve. There's no fractions involved. We just need to get all of our variable terms on one side and all of our constants on the other. So I'm going to move the 49y over here with the 3y. And I'm going to move the 224 over here with the 196. So after that step, we've got 52y equals whatever the heck 196 plus 196 is, 392. And the last step is division. We've got to divide both sides by 52. What's that give us? 392, oops, 392 divided by 52. An ugly number. What is that as a fraction? (98 over 13). Okay. Here we're asked to find an equation of the line with the given y-intercept and the given slope. So it looks like this is our y-intercept and this is our slope. And we just have to remember the slope-intercept form of a line is y equals mx plus b. That's the slope-intercept form, which makes sense to use because we were given the slope and the y-intercept. So what we can do here, we actually already have the information we need. y equals our slope, which in this case is -6, x, and then b is -16. So not too bad there. Shouldn't be too tricky of a question. Number 7, we need to solve the inequality and graph the solution. Well, we treat these just like normal algebraic equations. We'll kind of treat this as an equal sign. So we need to get k by itself. So I'm going to divide this side by -4 and this side by -4. And there's one rule to keep in mind. And that is if you divide by a negative, so -16 divided by -4 is a +4. If you divide by a negative, you've got to flip your symbol, all because we divided by a negative number. So we're going to flip our symbol in the opposite direction. So we get k is greater than or equal to 4. And they also want us to graph that, so I'll draw a number line here. And I'll put 4 up there somewhere. And k is greater than or equal to 4. Well, greater than 4 would be in this direction, right? Anything towards infinity. Equal to 4 means we will use a square bracket. And that would be the graph of that inequality. Number 8 is a word problem I included in here because I feel like a lot of students have been getting stuck on these word problems. But they're not too bad. You just need to pull out the information that's given and don't get lost in all of the other details. So let's look at this. The cost to produce X units of wire is C equals 35X plus 500. So that equation they gave us just now is the cost. It represents the cost to produce X units of wire. That's probably an important piece of information. So I'm going to write cost okay. Then it says, well, the revenue is this. So this represents the revenue. Revenue is how much money you bring in total, not your profit, but the money, just the total money you bring in. Okay, and they want you to find all intervals where the product will at least break even, where the product will break even. So revenue is the money we're bringing in. Cost is, of course, how much it costs to produce our product. So let's think about this. If our revenue was less than our cost, we'd be losing money, right? If we're bringing in less money than it costs to produce, then we're losing money, right? So we don't want that. We want to know where we'll at least break even, meaning we'll at least be able to cover our costs, or maybe even make some money. And the only way that happens is if our revenue is greater than or equal to our costs. That's when we can begin making money, or at least break even, meaning we've made just enough money to cover our costs. So this question is asking, where will the revenue be greater than or equal to the cost? So where will 60x, which is our revenue, be greater than or equal to our cost? So this is just a inequality problem just like we did up here. Solving this, we just need to treat it like an equation, get all of our x's on one side. So I'll move the 35x over here. And we'll have 25. 25x is greater than or equal to 500. And we finish this off by dividing. X is greater than or equal to 20. So what is this telling us? Well, X represented units of wire. X units of wire. So in order for our revenue to break even or start making us money, then we need to produce greater than or equal to 20 units of wire. 20 units of wire. And that's it. Not too bad. 2 equations, we set up an inequality, and we solved. All right? So again, those are problems pulled straight from the test review. So if you can do these problems, you should have a pretty good grasp of what will be on the exam.